Alright, the very last screencast of this unit, and I apologize for the number of screencasts in this unit. There usually won't be 8, but this is a pretty dense unit, and I wanted to separate them out into clearly identifiable concepts. So there it is. Anyway, this one's entitled Consumer Behavior and Utility Maximization. And this is essentially about how consumers go about deciding how much of something to buy when there's choices. Because up to this point, we've looked at single supply and demand curves, and you may have wondered, well, why that quantity for that price, etc. So this is about how consumers go about deciding between various products and deciding how much of certain products to buy. Alright, so the main idea is to deal with this question. How do or should consumers make decisions about what to buy in such a way as to maximize their utility? So I want you to imagine that you're in the market for a television, a new television. You walk into a store and you see these two televisions, the one on the left and the one on the right, and you have to decide which one to buy. Let's just assume that there's only two to choose from and you're definitely going to buy one of these two. Well, there's a couple things you probably want to know about these televisions. So let me give you a little information. First off, the price of the television. The one on the left costs $1,000, the one on the right costs $200. Now, of course, you can't really decide whether to buy or which one to buy simply based off the price, because there's other things you want to know too. How big are they? That's what she said. How big are they? How bright are they? What's the warranty like? What kind of features do they come with, etc. Really, what you're trying to know or trying to get a sense of is how much utility, how much happiness am I going to get from these various televisions? Different features and warranties and etc. will give you different levels of utility. So let's say that we could actually figure that out. And let's say that you decide for yourself that the television on the left would give you 2,000 utils, units of happiness, however you want to define that, of utility. And the one on the right would give you 1,800 utils of happiness. Is there a clear choice of television now? I'd suggest that there might be. You're probably doing some calculation in your head, whether you know it or not, and the calculation you're doing is essentially this. How many utils am I getting per dollar that I spend on that good? Or in other words, how much bang for the buck am I getting from these things? The one on the left costs more and gives me more utility, but the one on the right costs a lot less and gives me almost as much utility. It seems like the one on the right is a better deal. You're getting 9 utils per dollar that you spend on the one on the right, and only 2 utils per dollar for the one on the left. Now remember the law of diminishing marginal utility. What that said is that the more of something you do or consume, at some point the marginal or additional utility you derive from it will begin to decline. Again, the 7th taco that you eat isn't quite as delicious as the first taco. Well, we might construct a chart and a graph to kind of map out what utility is going to look like as you continue to eat tacos. In the graph on the top, I'm graphing out total utility, total happiness from various quantities of tacos. And in the graph on the bottom right, I'm going to map out marginal utility. How much extra happiness am I getting from each taco I consume? So let's say you eat the first taco and it gives you 10 units of utility. That would be 1 point in the graph in the upper right. The marginal utility of that first taco is 10. You're getting 10 more units of happiness than you were getting with 0 tacos. Let's say that 2 tacos combined would give you 18 total units of happiness. Again, the marginal utility of that second taco is only 8. You're getting 8 additional units of happiness by eating that second taco as opposed to only eating 1 taco. Here's what it might look like for the third taco, and the fourth, and the fifth, and now you're nauseous, and now you're vomiting. Notice diminishing marginal utility. Here it's happening pretty much right away. The tacos you're consuming are giving you more and more utility in total. Notice the total utility numbers are going up, at least until this point. And then as you continue to eat tacos, that 6th taco isn't really doing anything for you, not making you feel better or worse. And on the 7th taco, you're actually starting to get nauseous. Notice that marginal utility is starting to go negative and total utility is actually starting to go down. You're better off with 5 tacos than you were with 7. All right, that was the idea behind diminishing marginal utility. The more you consume of something, eventually, and here it's happening pretty much right away, the less additional satisfaction you're getting from that good. And since all goods, and I challenged you to think about this a while ago, since all goods or services are going to exhibit this quality, we're going to see diminishing marginal utility with pretty much everything we consume. All right, so we have a rule for how you can go about buying products in such a way to maximize your utility. And the rule looks like this. You should spend your money, the consumer's money should be allocated, so that the last dollar you spend on each product you buy should give you the same amount of extra marginal utility. Or in other words, for the last unit of everything that you buy, you want to be getting the same bang for the buck from your money. Because if you're not, you're probably better off changing your allocation to buy a different combination of goods. To put it into formula form, what we're looking for is this. We want the last unit of everything we buy, whether it's good A or good B or what have you, to be such that the marginal utility that we're getting from that last unit divided by its price is equal to the marginal utility we're getting from the last unit of any other good divided by its price. We want this bang for the buck to be the same from everything that we're buying in the end. So I'm going to run you through an example. It's going to be complicated. You're going to have to think about it. And you're going to see examples like this on the AP exam as well. All right, so let's take a guy named Merrill, who's actually the name of a student I had last year. Let's say he has $10 to spend. That's his income. Now also imagine, to keep things simple, that there's only 2 goods in the entire world, good A and good B, that Merrill can go about buying. And let's say good A costs $1 each and good B costs $2 each. The question that we're going to try to answer is, how should Merrill spend his money so as to maximize his utility, to get the most possible happiness out of his $10? So what we're going to do here is set up a little table. In the first column, I have units of the product, first, second, third, etc. In the second column, I have the marginal utility for product A. If Merrill buys the first unit of product A, he's going to get 10 additional utils worth of happiness. In the third column, I have marginal utility per dollar. I'm taking that number 10 and dividing it by the price of product A, which again was $1, which gives me 10 divided by 1, or 10. The green side represents the information for good B. That first unit of good B is going to give him 24 utils. And since good B costs $2 each, he's getting 12 utils per dollar that he spends on that first unit of good B. So we're going to start spending his money until all of his money has gone away and see exactly what it is that he winds up buying. Now you might look at the marginal utilities, but again, that would simply be like looking at 2 television sets and seeing which one is nicer. We can look at the marginal utilities, but really what we're more interested in is the marginal utility per dollar. Right? That's what's showing us the bang for the buck from each of these goods. And if Merrill only had to choose between the first unit of good A and the first unit of good B, it looks like the first unit of good B is the better choice. He's getting more bang for the buck, 12 utils per dollar as opposed to 10 utils per dollar. So the first thing that Merrill should buy is good B. Better deal, more bang for the buck. And since good B costs $2, notice that he now has only $8 left. All right, well, what if we had the information for all the other units that Merrill could possibly buy? We know that he just bought 1 good unit of good B. The question is, what would he buy next? Again, what we're looking at is the marginal utilities per dollar. He could either buy his second unit of good B, because he already bought the first, or he could buy his first unit of good A. And in this example, you'll notice that the marginal utilities per dollar are equal. He's getting the same bang for the buck from the second unit of B as he would be from the first unit of A. So since he has enough money to buy both of them, he will wind up doing that. Since good B costs $2 and good A costs $1, he's just spent $3 more, which leaves him with $5 left. All right, so far he has 2 units of good B and 1 unit of good A. Can you see what he's going to buy next? Again, he's going to compare the marginal utilities per dollar for the next units that he hasn't bought yet. Good B would give him 9 utils per dollar. Good A would give him 8 utils per dollar. He should buy that third unit of good B. That costs $2 more, so now he has $3 left. With that $3, he's then going to look at the next available units. He can get that next unit of good B or that second unit of good A. And again, here those two are equal, and since he has enough money to buy both of them, that's what he'll wind up doing. Notice that his income is now gone. And notice that more importantly, our rule is satisfied. For the last unit of each of good A and B that he bought, the marginal utilities per dollar, MU divided by P, are equal. 8 is equal to 8. Merrill has spent all of his money, and for the last unit of each of the goods that he sold, that he's bought, he's getting the same bang for the buck. Now you can add up the utility that he's getting from 2 units of good A and 4 units of good B, and you'll see that there's no other possible way that he could spend his money and get more utility out of that $10. All right, kind of complicated. You probably have to go through that a couple of times. But let me show you a typical exam question that I see on the AP exam pretty much every year. Let's say that John spends all of his money on 2 goods, X and Y. The marginal utility per dollar for the last unit of X he buys is 10. And the marginal utility per dollar of the last unit of Y he buys is 5. Now to maximize his utility, what should John do? He's obviously not doing the right thing, because again, for the last units that he buys, those two numbers should be equal. Which should he buy more of? Which should he buy less of? What should he do? Now notice in this example that the marginal utility per dollar of good X is higher than it is for good Y. Since John is getting more bang for the buck from good X, he should reallocate his money to spend more of it on X and less of it on Y. And if he does that, he'll eventually satisfy that rule, because remember, diminishing marginal utility. By buying more of good X, the marginal utility per dollar will begin to decline. By buying less of good Y, the marginal utility per dollar will begin to rise. Again, if I take you back to the example I showed you, you'll see exactly why. Notice that the more and more you buy of something, the marginal utility per dollar goes down. And the less you buy of something, the marginal utility per dollar goes up. That's because of diminishing marginal utility. Look at what's happening to the marginal utility numbers. All right, at some point, he'll buy these in a certain combination for which the marginal utilities per dollar are equal, and at that point he'll know that he's maximized his utility. Okay, hope that wasn't too complicated, but that's something that I can help you out with in class, or on an optional day. I'll be sitting around and I'll be waiting for you. Good luck on the test.
Oh! Oh my God!